Today's video is going to be about estimating square roots. I couldn't find one big video that I really liked, so I'm including a couple of small videos. Here's the first one.
Finding and estimating square roots, Wassmuth. Hansel and Gretel, cooking that witch in self-defense. Little did they know she had security cameras. Hansel and Gretel's square-shaped cell is just 18 square feet, but these jailbirds have a plan to fly the coop. So that was the first plan. Their second plan is dynamite. And you estimate the length of the wall they'll need to blast. To find the length of one wall, we need to take the square root of the area, or 18 square feet. Unfortunately, calculators aren't allowed in maximum security. Calculator! We'll need to estimate. To do this, factor out 18. 3 times 6 equals 18. Factor again until all the numbers are prime. This gives us the square root of 3 times 3 times 2. Now we can pull any doubles out of the box, like those double 3's. This gives us 3 times the square root of 2. We can't know the exact amount because of that darn no calculators rule. But we can estimate the value of the square root of 2. We know that the square root of 1 is 1, and the square root of 4 is 2. So we know that the square root of 2 must be a little bigger than 1. 3 times a number a little bigger than 1 is a little more than 4 feet. We can now estimate our wall length, which is a little more than 4 feet. Terrific. Now Hansel and Gretel can break free and head directly to a Weight Watchers meeting. Calculator!
Alright, that's the first video. Now on to the second. This second video is also about estimating square roots, but it has a different method. Either method can work, but they're both good tools to have in your arsenal. So here's the second video.
My name is Melissa Wagner, and today we're going to be learning about approximating the square roots of non-perfect squares. First, let's review what a square root is. So, for example, the square root of 16 is 4 and negative 4 because 4 times 4 equals 16, and negative 4 times negative 4 equals 16. We can also represent this using colored tiles. So I have 16 tiles here, and the dimensions are a 4 by 4 square. But what about if we have 20 tiles, and I want to know what the square root of 20 is? I'm going to add 4 more tiles, but it's not a perfect square. So I'm going to replace them with a different color. And I still don't have a perfect square, so I'm going to add red tiles to represent the next biggest perfect square, which is a 5 by 5. So I know the square root of 20 is between the square root of 16 and the square root of 25, or between 4 and 5. But let's get a closer approximation. So to approximate the square roots of non-perfect squares, we find the biggest perfect square. That's going to be our whole number, the square root of that biggest square. And then the numerator is how many extra tiles were left as part of that non-perfect square. And your denominator is going to be how many total tiles were needed to create the next biggest perfect square. So I look at what my biggest square that I made is, which is my 4 by 4 square. That's going to be our whole number, the square root of that biggest square. So I look at how many yellow tiles I have, which are 4, and then I look at how many tiles I needed to make that next perfect square. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So my approximation is 4 and 4 ninths. And we can check this on a calculator. And I get about 4 and 44 hundredths. And then I'm going to take the square root of 20, 4 and 47 hundredths. So it's a pretty close approximation and much more precise than just saying between 4 and 5.
All right, there's a second demonstration on how to estimate square roots. Now we're going to see an actual problem done with a number line, which is another way to estimate square roots. All Alright, so this is an example. It's actually from the online version of your textbook. And so this actually is using a number line to estimate a square root. And I thought it was kind of funny that this is Mr. Hardesty teaching. Make sure our volume is all the way up. Alright, here's that video.
This is Mr. Hardesty. Let's estimate square roots. Estimate the square root of 28 to the nearest whole number. The square root of 28 is equal to a number that is not a whole number. We're not sure what that number is. So let's find the nearest whole number. The square root of 25, which we see here on the number line, we know the square root of 25 is 5. That's a whole number. The square root of 36 that we have here at the other end of our number line, that's equal to 6. So we can see that between the square root of 25 and the square root of 36, there are many other square roots. These two represent the nearest whole number, 5 and 6. Let's place the square root of 28. 28 is closer to 25 than it is to 36. So right in here, we'll approximate and place the square root of 28. We're to find the nearest whole number, and the nearest whole number would be 5. Square root of 28 is closer to the square root of 25 than it is the square root of 36. So our nearest whole number would be 5.
Alright, so that's tonight's video. I'll see you all in class tomorrow.